You see here how I've got the baffle control as the energize? Well, if I don't have that energized, even manual isn't going to function. So having baffle control directly on that energize, that's not going to work. So what I need to do is I need to set up something that handles an actual energized bit and turns this thing on and off. So let's go ahead and bring in an assignment, and this is going to be baffle PID on. I'll just say on, and let's copy that, and that's actually what's going to turn this on. And then same thing here, I want an oil pump VFD on. Right click, and I'll go ahead and define these two. So this is going to be global bool. This one's also going to be global bool. And I'll copy that just so I don't forget it, even though I'm not working this rung right now. But I'll just drop that in there on an assignment. So there we go. So that's going to turn these on. And when do we want it to be on? Well, let's come over here, and I'm going to look for a comparator that says not equal. And I am looking for the baffle HOA to not be equal to 0. And I'll copy that because I'm writing two rungs of code at the same time. And this will be my VFD HOA. And as long as that's not equal to 0, then it's going to be on. If it is equal to 0, then the first thing, then something else I want to do, and I want to do that down here, is I want to set these percentages equal to 0, because I don't want them to be left on something that they're just running like crazy. I want them to be off, and with the output signal going to the module being 0. So down here in this last network is going to be PID off handling. Kind of give it a nice vague name. So the first thing I want to do is I want to come down here. Actually, I can go up and grab my comparators. So baffle HOA is 0. That's what I'm looking at for the first rung. And on the second one, I'm looking for my VFD HOA to be equal to 0. So if those are equal to 0, and I want to do this perpetually to make sure that nothing overwrites them later on. So these aren't going to be on one-shots at all. And I'm going to move a 0.0, 0.0 into, actually that can be a 0 because I'm writing out to an int, right? Yeah, so I don't need to write that as a real value. I can just write that as an int value. And that's going to be my baffle percent and my VFD percent. Okay, so anytime these are turned off, we're going to just manually come down here and write those values out at 0. Otherwise, if we're energized, if we're in hand or auto mode, then this should be energized. And unless we're in manual mode, then we'll be running automatically. If we are in manual mode, then we're going to be running in manual, obviously, and we're going to be dictating what the output is. And then I still don't think we've got full control over our settings coming in. So for our set points, what do we have on the different modes? I'm going to go into function block, not function block alarms. I want to go into function block modes. And I just want to look back through all the modes and see if we actually have set points for these. Because assuming we're in auto control mode, we want to be running. And actually, we're engaging the controls in these, so I think we're good on that. Otherwise, we're going to just drop to 0. Okay, so I think that's going to work. And at this point, I think we can go ahead and run this thing up on the simulator and start trying to figure out where we're at. So let's do it. Let's see if it compiles. I don't think I have any logic problems in there because there was no new STL being created, and that's usually where I get screwy. So if I was doing everything in ladder or function blocks, chances are it's going to work right off. Or not, maybe not work right off, but at least compile. I usually don't get that sloppy when I'm writing that. But while I'm writing and trying to teach and talk through everything, obviously that's an added complication. So yeah, I made it this time. Everything compiled. Okay, that's cool. Let's get it on the processor. Let's start our module. Okay. Let's try and figure out where we're at. It's going to be real hard jumping back and forth between everywhere we need to go. So even though it's boring, I think we need to use a watch table. So let's go in here. Let's go online for starters. And let's see what we want to look at. I think we're going to look at probably a lot of this stuff. And yeah, we're looking at modes and things like that. And I think we also want to look at our VFD figures. So let's pull up baffle control and baffle HOA. Let's try baffle PID on. Baffle, I think we've got a set point for that, right? And we've got a percent we'll look at. And where's our set point? We've got a baffle manual set point. And where's just our normal, yeah, baffle PID set point. Okay. And then we need our baffle auto push button. Our baffle off push button. Oh, there's our auto. Oh, we already got our auto. Crap. Baffle hand and baffle off. Where is baffle off? There it is. And there's one more piece of logic that I don't think we have, and that is when somebody tries to start this thing and put it into start mode, do we allow it to start if all of the devices aren't in auto control? You see how that can be a problem. So let's go in here, and yeah, when somebody pushes the start button, we're just calling the start sequence bit and we're leaving it at that. So I think it would probably be very wise to also put everything into auto control at that point. We could do it one of two ways. We could just prevent the start button from being pushed if everything's not in auto. I think maybe we do it that way just to be on the safe side, because that makes somebody manually put everything into auto in case they're forgetting that something is off for a reason or something is being manually operated. So let's go ahead and let's do it that way. So I'm going to work in our IOs for starters, and for all of these devices, I want to set a bit for being in all auto. So let's come down here to network 4, and I'm going to start with an and bring that down here. And for the network name, I'll just call this full auto bit. And I can actually space that out because that's not a tag name. There we go. And what I want to do with this is I want to do an assignment. So let's bring in that assignment, and we're going to be assigning that full auto bit. So let's right click and define it, and that's going to be a global bool. And what we want to look for here is all of our devices. And you know what? While I'm thinking of all of our devices, you know, we've got an alarm horn that I don't think we've even programmed yet. So I guess we've got some cleanup to do before we actually run. Bummer, right? So let's start. We're going to need to pull in comparators, and we're looking for equals. And we're going to start by looking for our baffle HOA to be equal to 2. I hate it when it does that. I click on something, but it doesn't actually click. Okay, copy that, paste it in here. Okay, it doesn't seem to want to let me. Let's try that again. Alright, there we go. And we need to do that for basically all of our devices. Fortunately, we don't have a lot of devices. Unfortunately, I don't really remember how many devices we have, so we'll figure that out as we go, I guess. And okay, so that ought to get us started off. So we want to make sure our oil pump VFD HOA is set to 2, and that takes care of both of our PID things. Let's check our alarm horn HOA. We also want to look at our brake HOA. It could be disastrous if the brake was locked in and we're still trying to run a system. That could be a big bummer. We've got our station interlock HOA. And I'm going to look back up here just to see what I'm forgetting. Oil pump, brake, alarm horn, interlock, our baffle, and yeah, maybe that's it. It is. So what have we got here? 1, 2, 3, 4, 5, 6 devices. That's pretty simple. So that's going to set us up for full auto bit. And we also want to control, and rather than assigning that bit, I think we might need to set that bit, because if we're switching back and forth between paradigms, if we're just using assignment, that's probably not going to work. So let's go ahead and delete that. Come over here, and we're going to use a set. So we're going to set that full auto bit. And just like we've got a set, unfortunately we're going to need a reset. So I think I've got all of that copied. Let's come down here and try to paste it in. Yeah, we do. And this is going to be an OR. So instead of these being equal, we're going to set them all to not equal. And we're going to say if any of these is not equal to 2, and then we're going to reset our bit. So if any single one of these is not equal to 2, then we're going to come down here and reset this bit. Okay, so we've got it done in function blocks. Now we got to do it in ladders. So full auto bit, and same thing, we are looking for comparators, and our double equals, we're looking for things to be equal to 2, copy 1, 2, 3, 4, 5, and if we get all of those, then we're going to do a set, and that's our full auto bit. And we are looking for baffle HOA, we're looking for oil pump VFD HOA, we've got our alarm horn HOA, our brake HOA, our station interlock HOA, and you know what? I think that's everything. What else did I have on IO here? You know what? I've got baffle on top and then I've got baffle again on bottom. That's the problem. Let's delete that. And then let's delete that extra condition. Yeah, that's it. Okay. Getting closer. Come back to our I/O. Yeah, we can delete that. So if all of these are set equal to 2, then we're going to go ahead and set our full auto bit. And let's come down here with another rung. Paste in that logic, and now we need to do a couple of things for our reset. So first let's set this up as a reset, then set all of these up as not equal, and then we're going to need to parallel all of these instead of having them in series, because in series means and in parallel means or. So we've got 4 more conditions down here. Let's move these guys all down to their own branches, and then we'll just connect them all up. And the drag and drop just doesn't really want to work all smoothly, but it's TIA Portal, so we already know that the software is not exactly optimized. Okay, let's connect all of these things up. And I think we've got those bits controlled in 2 languages. Hopefully SCL and STL will be a little bit easier to write. So down here, yeah, we'll just go ahead and put it down on the bottom like all the rest. So comment full auto bit, and we're going to say if baffle HOA equals 2 and alarm horn HOA equals 0, and we want our oil pump VFD HOA. And where is that guy? Oil pump VFD HOA equals 0, and station interlock HOA equals 0, and brake HOA equals 0, then full auto bit colon equals 1 semicolon, else full auto bit colon equals 0 semicolon, and underscore if semicolon. Okay, that's it for there. Now let's do our STL. STL is always the pain, but I think we had a pretty smooth code in here. Yeah, it wasn't so bad. I can go ahead and put this, where do I want to put this? Do I want to put this at the very end? I've got all of these calls, and yeah, I can. It's running right to the end anyway. So let's go ahead and put it here. Full auto bit. And let's start by clearing out our register. And then we're going to say and. Oh no, we've got to do equivalence. I forgot about that. So we're going to load the baffle HOA. Then we're going to load 2. And then we're going to check to see if those are equal. And then we're going to say if not, JC, jump conditional, end of line, which isn't defined yet. That's a good thing. So let's go ahead and put that right here. End of line, semicolon, block end. And actually, instead of jumping to an end of line, I'm going to leave this end of line here, but I'm going to jump to reset full auto. So let's copy that. And don't worry, I'm not going to get too crazy on my structure here. This is going to be set, and then we're going to have not, and then we're going to reset, not reset, but full auto bit. And then we will jump unconditionally to end of line. All right. So then let's assume we don't jump conditionally. Then we need to evaluate the rest of our devices. And actually, let's just copy all of this because we're really going to be doing the same thing. So let's clear it, and now we're looking for our oil pump VFD HOA. And if it's not equal, go to reset. And now we're looking for our alarm horn HOA. And if it's not 2, go to reset. And then we're looking for our brake. Whoops, that's not what I wanted to be setting. So let's Control Z a couple of times. It's a really slow process. There we go. So let's check our brake HOA. And what have we got? We've got baffle, oil pump, alarm horn, brake, and I think we just need our station interlock. So station interlock HOA. If not, jump. And if we come down here, we're going to clear, then we're going to set, and we're going to set full auto bit. And yeah, I think we can do it just like that. And then we will jump unconditionally to end of line. Alright, yay, more STL to have to debug. Okay, so I think I've got all that handling in there. And you know what? At this point, let's see if this compiles. And I think we've really kind of got a full lecture here, so yeah, we might just go ahead and take a break before the next.